So today is practical kinematics 2, and we are going to study relative motion. Relative motion. So I give you an example. What is relative motion? You are driving a car on the road with a speed of 60 miles per hour. So 60 miles per hour means that the speed of your car with regard to the road. But compared to you also with the road is 60 miles per hour. However, if your speed with regard to the car, because you're sitting on the car, so the relative velocity of you with respect to the car is zero. So that we call it relative motion. So basically, relative motion is the motion of one object with respect to the other object. And it involves the calculation of the motion of one object with regard to some other moving objects. So for example, the previous example that I talked to you, that is the two moving objects is your car and yourself sitting on the car. So let's give one YouTube video. You have it here.
Have you ever wondered as to why a train coming from the opposite direction appears to be faster than a train moving in the same direction? To answer the above question, we have to understand relative motion of objects. Consider a passenger sitting at the window seat of a train as an observer. Case 1. When the train in which the observer is sitting is moving with a velocity v1 of 30 km per hour, and another train is coming towards the first train with a velocity v2 of 60 km per hour. In this case, from the frame of reference of the observer, it appears that train coming towards him is moving faster at a speed of 30 plus 60 is equals to 90 km per hour. Whereas, from the frame of reference of a person standing on the station, both the trains are moving with velocities of 30 km per hour and 60 km per hour. Hence, in the case of train moving in opposite direction, from the perspective of the observer sitting in one of the train, it appears that approaching train coming from the other direction is moving faster with net velocity being the sum of v1 and v2.
So that one example that you can see about relative motion. The other example that I'm not sure you experience, for example, at the stop sign, you stop your car waiting for the green light, and then a big truck or a bus approaching in the other lane in the same direction. And when you driving and you see the bus, you feel that it seems like you are backing up your car while you are stopping. It happened to me, so that I say, did I already back up, or did I forget to take my foot on the brake pedal? So things like that. As you can see, it all relative motion. I'm going to show you the situation at the stop sign when you stop your car waiting for the green light, and another truck or another, for example, school bus come, and then you feel that you are driving backward or back up your car. So we do that later. But before that, let's talk about the concept of the relative motion. And basically, definition is here too practical. Using translating exit. Access. So let's talk in 2D. We have two axes, X and Y, and the origin is O. We have two particle A and particle B. Particle A, particle B, let's put A there. And just like in 2D forces or 3D forces, we talking about the position vector in 3D forces. So for point A with respect to O, we can have position vector R, and let's call that RA. And then to particle B from O, we can have position vector RB. And position vector 2A, 2B from A, 2B from A, we can have that is R 2B from A. And let me, because this is a relative motion, we want to see how B move relative to A. So let's have another axis, we call it translating axis, X apostrophe and Y apostrophe. And this one is translating as A moving, translating. And of course, X and Y just like on the road. So we have a fixed axis, X, Y. So from your vector equation for the position, I can have B, position vector from O to B, it will be equal to position vector A plus position vector 2B from A. So just keep in mind when it B, let me change the point here. So the color at B here, then you have to have the B in there. So don't confuse. So it's RB, then RA plus RB relative to A. Keep that in mind. So with that, we can do with the velocity. So let's talk about velocity, because basically in relative motion, we want to calculate the relative velocity and relative acceleration of one moving object with respect to the other moving objects. So let's talk about velocity. And we already know in the practical kinematics 1, if we take the first derivative with regard to time of the position vector, you can get the velocity. So let's do that here. If we have that equation, so let's take d over dt r b. So we will have b, we have d over dt ra plus d over dt r vector from A to B. And RB relative first derivative of the position vector B with regard to time, it actually that is VB. So that is VB. Similarly, dRA over dt, that it will be V velocity of particle A. And then this RBA from A to B with regard to time, first derivative. So we have that it will be V relative to A of particle B relative to particle A. And this equation, we call that a relative velocity equation. Relative velocity equation. So what is VA, VB, and VA relative to B? So VA, VB, very simple. VA, VB, that's something we are familiar with. Basically the absolute velocity, measure with regard to the fixed coordinate X and Y, or your car with the road, right? So measure with regard with regard to x and y axis. So a fixed one. And what is VB relative to A? VB, and that is the one that we study, relative velocity. VB relative to A is mean the relative velocity of particle B relative to particle A. So with that, it basically we have the velocity of B as if A was not moving. A were not moving. So basically that are the note about the relative velocity. So you have relative velocity equation, if VB equal to VA plus VB relative to A, or you can have, if you talk about the velocity of A relative to B, then you have VA equal to VB plus VA relative to VB. So with that equation, I want to apply to the example that I stated earlier. So you are stopping at the stop sign. So at that one, let's call you are A. You are A. And VA in this case, as you can see, at stop. So the velocity is VA is 0. And then the bus, for example, it approaching the stop sign and about to stop. So let's call it that V bus. And it's about 5 miles per hour. So if you are driving the car, you look at the bus, it seems that you are backing up, but you already stopped. So sometimes we are panic. What's going on? So I can show you why it looks like we are backing up.